Welcome to today's lesson on Factorizing Quadratics. Today we'll be looking at how do we take a quadratic and factorize it into two brackets. Hopefully you've had a go at the starter questions, and we will, as always, go through the solutions to these. This first question has asked us to solve the equation 4x minus 4 all over 3 equal to 20. So when looking at an equation like this, the first thing that you should realise and always want to get rid of is a fraction. So we don't like this divide by 3. And as you can see, this divide by 3 is currently, you could think of this as trapping all of this on top. Our goal is to get x on its own. So the first thing we should deal with is definitely the divide by 3. So the first thing we'll do is get rid of divide by 3. The opposite of divide by 3 is to multiply by 3. Remember, you always do the opposite to both sides to keep it equal. And that would give us, well, if I times by 3, and I've discussed this in my algebraic fractions lesson series, if I times by 3 here, I'm actually just getting rid of the divide by 3. A lot of students times this and this by 3. You don't have to. All you do is write down what was on top anyway. So we've eliminated this divide by 3 and we're left with this. 20 times by 3 would be 60. Now it's just a basic solving equation. So we're going to add 4 to both sides, which would give us 4x equals 64. And then we're going to divide both sides by 4. And if you don't know how many 4s go into 64, a good method in any test or when you're practicing is to just do a bus stop long division. So 6's into 4 go once, with 2 left over. 6's into 24 go 6. So the answer to this would be x equals 16. Okay, so that takes us on to the next question, which is expand and simplify. So we have got two brackets here and we need to expand and simplify. Well, hopefully expanding, you remember, is just multiplying everything in the bracket by what is on the outside. So that would give us 2 times a would be 2a, 3 times 2 would be plus 6. Now, this next one, it's very, very important, and I say this a lot, that you remember that this 3 is not 3, it is in fact minus 3. The minus is attached. Anything to the left of a number or term is attached. So if you've got a minus, it is attached to that 3. This plus is attached to that 3. They're not floating, they are attached. So we've got to do minus 3 times by 2a. Well, 3 times 2a would be 6a, and a minus times a positive, a mixture makes a minus, so that would be a minus 6a. Next, minus 3 times by minus 4. Again, that is not 4, it is minus 4. And it's really important that you understand that. So minus 3 times by minus 4 would be plus 12. So I have done, if you look at the question, I've done the expand part. Now I need to simplify. So by simplifying, it's going to give me, well, what like terms do I have? I have 2a minus 6a, again the minus is attached. 2a minus 6a would be minus 4a. That'd give me minus 4a. And then we have the 6 and the 12, which we can put together because they are in fact like terms. They are whole numbers. So 6 add 12 would be 18. So minus 4a plus 18. Where students fall into mistakes here is with these negatives. Okay, so just be clear on how our negative and positive numbers work. From here we're done. Lots of students, they try and solve this now. They try and take away 18 from both sides, but there is no both sides. This is done. We have expanded and we have simplified. We don't need to solve. See it all the time. That's your answer. You don't need to do anything else. Okay, going down to the bottom left, we'll be finding the volume of this triangular prism. So, like Toblerone, how do we find the volume of a prism? Remember, to find the volume of a cube or a cuboid, you just times base times height times length, base times length times height, however you say it. You just times them all together. Well, you can't quite do that with a prism. You have to remember that the volume of a prism, V equals the face area times by the length. Okay, the face area times by the length. So the cross-sectional face area is the area of the face, exactly how it sounds. And the length is the length of the prism. So we can see clearly, hopefully, that the length is in fact 10. The thing that we need to find is the face area. We need to find this face area. Well, if we focus on the face area, what is it? The face area is a triangle. The area of a triangle is base times height divided by 2, where the base is 5 and the height, remember with a triangle you have to have the perpendicular height, the right angle height. So 5 is not the height, 6 is the height. So that would be 5 times 6 divided by 2. 5 times 6 is 30, divided by 2 is 15 centimeters squared. So the area of this face is 15 centimeters squared. We now have all of the relevant information that we need to solve this and find the volume. The face area is 15 times by the length, which is 10. 15 times 10 is 150, remember, centimeters cubed for volume. Simplify. Now this is going to require our laws of indices. This is a series that I've done on this YouTube channel. If you are unsure about this question, you should go back and watch indices 1 and 2. It would make this very, very easy for you. The only way you can do indice questions like this is by knowing the laws. If you don't remember the rules, they're very difficult to do and get correct, but the laws in themselves are very simple. So how do we do this? We have got 3ab squared c to the minus 2 times by 4a squared b cubed c to the 7. Well, the key bit here is the times in the middle. When you times indices with the same base, you can simply add the powers. So to recall, a to the power n times by a to the power m equals a to the n plus m. They have the same base. You're timesing, so you add the powers together. Well, we've got a lot of different bases going on here, so we should just take them step by step. So we're going to focus initially on the whole numbers. 3 times by 4. Well, 3 times by 4 is 12, so that would give me simply 12. Now let's focus on the a's. We've got a and a squared. Well, in that lesson series I told you if there's not a power, you should add a power 1 in. There's technically a power 1. So what does that mean? We've got a to the power 1 times by a squared. Remember, we add the powers together and keep the base the same. So keep the base the same, a, add the powers. 1 add 2 would be 3. Or you could just think a times a squared. Hopefully you know that will just give you a cubed. Hopefully that's just a rule that you understand. Next, if we focus on the b's, we've got b squared and we've got b to the power 3. Timesing those together, you simply keep the base the same, b, and you add the power. So 2 add 3 would be 5. Done. And we can do the same for c. C is going to be, find a colour, c to the minus 2 and c to the 7. Well, keep the base the same, c, add the powers. Minus 2 add 7 would take you up to 5. So our final answer is 12, a cubed, b to the power 5, and c to the power 5. So 4 very different topics there. Hopefully you managed to do those successfully. And hopefully if you didn't, my answers helped. So this takes us on to the lesson, which is Factorizing Quadratics. And I've called it Factorizing Quadratics 1 because it is going to just focus today on the basics of Factorizing Quadratics, and we'll look at the harder examples in future lessons. The first thing that I've just said here is recall expanding a double bracket. So able to factorize quadratics, you should be able to definitely first multiply out two brackets. There are many different ways you can do this. There is the FOIL method where you draw your lines on. There is a grid method where you put it in a grid and you expand it out. I highly recommend to use the FOIL method just because it's quicker and less room for error, I would say. But if you use the grid method, that's absolutely fine. If we focus in on expanding out this first one, we've got x plus 3 multiplied by x plus 2. Well, the FOIL method tells us to do the first ones. So x times x would give me x squared. Then we're going to do the first one times the last one. X times 2 would be plus 2x. And then we come in and we do the last one times the first one. So 3 times x is plus 3x. And then 3 times 2 is plus 6. And hopefully you're confident at doing that. We can always simplify. As you can see here, we have got two terms in the middle of the same unknown, x. Remember, an x squared and an x are not the same. You can't put them together. They are unique. An x squared and an x are different. But we can put these two x's together. We've got 2x plus 3x. If I add those together, I'm going to get x squared plus 5x plus 6. So that is what I get when I expand out this double bracket. And that is what we call a quadratic. And we'll talk about why that is a quadratic in a moment. Okay. The main element that makes it a quadratic is the x squared. Okay, the x squared is what makes that a quadratic. And then we've got this 5x and a whole number 6 on the end. And we're going to go into what those things are and how do we turn this x squared plus 5x plus 6 into a double bracket. So how do we do the opposite of what we've just done there? So remember, factorizing is the opposite of expanding. So we're going to look at how do we go from this answer and turn it back into these double brackets. Okay, and we'll just look at one where we've got negatives. We've got u plus 6 multiplied by u minus 3. Well, if I multiply those out using the same method, u times u is u squared. U times minus 3 is minus 3u. 6 times u is 6u. And 6 times, now, as always, minus 3. 6 times minus 3. It is not 6 times 3. It is 6 times minus 3. 6 times 3 is 18. And a positive times by a negative is a negative. A mixture makes a minus. Again, we always will have like terms that can be put together. We've got a minus 3u plus a 6u. Well, that would give me just 3u. If you're at minus 3 and you add 6, you get 3. Or if you take away 3 from 6, you could think of it that way. You got u squared plus 3u minus 18. And again, we're going to look, how do we go from this quadratic and turn it back into this double bracket? And that one's a little bit harder because you've got positive and negatives. And as always in maths, as soon as you start having a mixture of signs, things become a little bit more difficult. Not impossible, but just you have to be a little bit careful when doing it. Okay, so that's the sort of preface to all of this. We're basically going to do the opposite of what we've just done there. So, what is a quadratic expression? We should start there. What is a quadratic expression? Well, we've just seen that these are quadratic expressions. I've told you they are. Okay, but what are they? In maths, we always want a generic way to explain something and show some sort of formula that can be applied to any situation with any numbers. So for example, you've seen that already today. I recalled here the indice laws where if you've got the same base times together, you add the powers. Okay, and then as you can see, I can take that rule, this very generic rule, and I can apply it to when I've got A as the base, when I've got B as the base, when I've got C as the base. So we're going to see if we can write down a quadratic, the general formula for a quadratic that will be applied to any quadratic. And what that is this. It is a x squared plus b x plus c. Okay, this is the general form of a quadratic. And what you can see there, and if I just keep the quadratic above and this one here with the u's in view, we can start to map these up and just discuss what this generic form relates to. What is A, what is B, what is C? So here we've got ax squared, so some number, and what we should say here is where, and this is really important, where A, B, and C are whole, well, we shouldn't say whole, where we'll just say they are integers. Okay, what does that mean? That just means that the A, the B, and the C are just whole numbers. Yeah, an integer is just a whole number. So I'll put that note there in case you're unsure. Just a whole number. And we can see that, can't we? If we look at this one here, x squared plus 5x plus 6, what would C be in this case? C would be the 6. Okay? C is the 6. What would the B be? Well, the B is in front of the x. What's in front of the x here? 5. So B in this case would be 5. And this is the interesting bit that students always forget. What is in front of the x squared? Well, there's nothing in front of the x squared. Does that mean A equals 0? No, it doesn't. Because if I put 0 in front of that, what's 0 times x squared? 0. It would mean it didn't exist. So it cannot be 0. What would A be here? Well, technically, A is 1, isn't it? And we know this, like x. If I write x, what does that mean? It means 1x. So if I've just got x squared, it technically means 1x squared. So what are these things called? We refer to these A, B's, and C's, well, the A and the B, as coefficients. They are coefficients, okay? So we'll say this is B, and it's the coefficient of x. What does that mean? That just means it's the number in front of x. Coefficient is the mathematical way, the fancy way to say the number in front of x. Okay, and in this case, the coefficient of x is 5. What is the coefficient of x squared? 1. Okay, so A is 1. If we are mapping this to our A, B, and C, here we could say that the A is 1, which means the coefficient of the coefficient of x squared, the coefficient of x squared is 1. That's what that means. Okay. And if you map this over to the u's, instead of x's, we've got u's, and that's completely okay. You don't have to just have x's. Here we could say that what is C? If I asked you what is C for this quadratic here, hopefully you'd say C is minus 18 because it maps there. The whole integer is C. If I asked you what B was, hopefully you'd say 3. If I asked you what A was, hopefully you'd say 1 because there is nothing in front of, there is no coefficient in front of u squareds, but technically we know it means one of them, so A would be 1. Okay, so that is the general form of a quadratic. It's how it maps up. Really good keywords are coefficient, integer, okay, and A, B, and C are very, very useful for more than just factorizing. To be honest with you, you don't actually need to know this very well to factorize, but having a deep understanding of it will make other things with quadratics much easier. For instance, the quadratic formula. Completing the square. These are all things where understanding what we've just gone through there is going to be really, really, really useful. So that takes us now on to, what does the graph look like? Well, the graph of a quadratic is a smooth curve that has symmetry. Okay, it is a smooth curve that has symmetry. We will do lessons on the quadratic curve and we'll look in detail about it, but for today's lesson, all I need you to know is a quadratic curve looks like that. You don't need to know how they work, how different elements of A, B, and C, when we change A, B, and C to different numbers, the curve starts to take a different form and move around. Yeah, but we won't look at that today. All you need to know is ax squared plus bx plus c is a quadratic, and they look like a smiley face, smooth parabola. Okay, and we will go on to lessons about that. So what we're going to do now is explore how do we relate this with some steps to go from this to these double brackets. Okay, that's the goal of this lesson. Well, when factorizing a quadratic expression, it will go into, well, hopefully you can see there, if it's the opposite of this, it's going to go into two brackets. So we can say it will go into two brackets. Okay, and it looks like that. It will go into two brackets. How do we do this? First of all, we need to put a case study. Let's look at a case study that we can explore. So if we expand out x plus 2 and x plus 1. If we expand that out, what are we going to get? X times x is x squared. X times 1 is plus 1x. Yeah, or plus x. 2 times x is plus 2x. And 2 times 1 is plus 2. And again, we can simplify as always the two terms in the middle. X plus 2x would be 3x. And the plus 2 on the end. So we've got x squared plus 3x plus 2. So how are we going to do this? How are we going to go from this, pretend we didn't know what this was, or this. How are we going to go from this and all of a sudden end up with two brackets? Well, we should look at A, B, and C. A, remember, is the coefficient in front of x squared. B is the coefficient in front of x. And C is the integer that is on the end, the whole number on the end. So I'm just going to write that in blue underneath. To really get your understanding going, we should explore this. I could just show you the method, but it's good to explore how this maps to the general form of a quadratic. So if we color coordinate this, hopefully you can see that B, our coefficient of B, or our coefficient of x, is 3. B is 3. C would be the plus 2. Our C is plus 2. And A is 1. Okay, A is 1. Well, if we think about factorizing this, we're going to need two brackets, aren't we? Two brackets. What is the only way? And remember, what are we doing to these brackets? We're multiplying things. Okay, we're multiplying each term by one another. So what is the only way I can get x squared? By timesing two x's together. So hopefully you realise that it's going to need an x. It's going to need two x's because x times x is x squared. The only way I'm going to be able to get the x squared is by multiplying two x's together. The tricky bit is, what are these numbers here? These numbers here are the tricky bit to find because what do they need to do? Somehow they need to generate 3 and 2, 3x and 2. Well, how does this work? Our two numbers are 1 and 2 in the brackets. How does that map to these two b and c values that we need to have? Well, hopefully you can see 2 add 1. What's 2 add 1? 3. And what is 2 times 1? 2. So the method here is we need two numbers that multiply together to get 2 and add together to get 3. And this all comes from this line here. You can see those two terms in the middle add and make 3. This number on the end came from 2 times 1, which is 2. So what could we say here? We could say that to factorize, we need, and I'm going to use the A, B, and C notation here, so I think it's really useful for you to understand. What do we need? We need two numbers that multiply to make, what do they multiply to make? Well, 2 times 1 is 2. So they multiply to make, if I was talking in the general form, multiply to make C. So we're going to highlight that. We need two numbers that multiply to make C and add together to make, and hopefully you might already be saying out loud, to make B. Yeah, 2 add 1 is 3. That is B, to make B. It's the coefficient of x is B. And that is it. If you can remember that when factorizing quadratics, you're going to be able to do them no problem. So what do we need? Just to recap, we need two numbers. Obviously we need the x. We need the x and the x to make x squared. The tricky bit is, what are the two numbers that I need? Well, if you can remember that they need to multiply to make C, which is the bit on the end, and add together to make B, which is the bx, the coefficient of x, you're going to be able to do it. So, this means that you need to know your factors, okay? You're going to have to understand how your factors work in basic number work and how positive and negatives work. So we're going to take this understanding that you need two numbers that add together to make B and times together to make C. Factorizing will become very, very easy. So I know that was a little bit long-winded and I could have just shown you how to do it and I could have just jumped into the method, but I really think there's value in you understanding how it relates to ax squared plus bx plus c. And if you can use that technical c and b and a when talking about quadratics, you're going to have a much, much deeper understanding of it, which means you will never forget, okay? What happens is when you just learn the technique, it just disappears out your head. But if you go into this and understand it, hopefully there's opportunity for it to stick more. Okay, so let's start to break this down into questions there where we can actually see it working, okay? Because at the moment, all we've done is looked at the inner workings of it and how it all comes together. Now we're going to see, here's a quadratic, we need to put it into two brackets. The first thing I've just put at the top of this page for you is a noteback for multiplying positive and negative numbers. It's really useful that you understand this because some of these examples down here are going to have positive and negative numbers. So all I've put here is a positive times by a negative gives a negative times by a positive gives a negative, and all you need to remember is a mixture of signs, a positive and a negative, are always going to make a minus. A mixture makes a minus. If you multiply together those two things, you will always get a negative. And then a minus times a minus is a plus. And a positive times a positive is a positive. So what does that mean? That means that if they're the same, it's a plus. If you can remember those two sentences, you're going to be absolutely fine. So let's get into example 1. Yeah, we've done enough rambling and talking about it now. Let's actually see it working. We need to factorize x squared plus 5x plus 6. Okay. What I'm just going to write up here as well, just above, I'm just going to write ax squared plus bx plus c, just so we can see it. Ax squared plus bx plus c. Okay. Well, what do we need? Factorize. Well, it means it needs to go into 2 brackets. That's something that we discussed. It needs to go into 2 brackets. We definitely know, don't we, that to make this x squared, we need an x and an x, because the only way to make x squared is to times x and x together. Okay. If we're multiplying, if we're talking about multiplying, we've got x times x is x squared. So we need to know, what do these numbers here need to be that when I expand it all out, I get this quadratic here? Well, what did we say? We said that we need 2 numbers that add together, okay, that add together to make b, which is 5, add together to make b, and multiply together to make c. Okay, they need to multiply together to make c. Well, c is plus 6. Okay, and you know, I'm being a little bit careless there. B is not just 5, it's plus 5, it's a positive 5. So I need 2 numbers that multiply together to make 6 and add together to make 5. Well, instead of thinking about this, the method I use is, I know they need to multiply together to make 6. So I'd put 6 in, and I'd write my factors of 6. What times together to make plus 6? Well, 1 times 6 makes 6. 2 times 3 also makes 6. Well, if these 2 numbers times to make 6, all I need to do now is check which ones add to make b, which ones add to make 5. Because all of these clearly make 6 when I times them together. Now, there's one other caveat that I need to add here. How else do you make a positive number? How else do you make a positive 6? By multiplying 2 positive numbers together, or 2 negatives. So what we could actually say here is, and this is really useful for certain examples, you could have minus 1 and minus 6, and minus 2 and minus 3. Because what is minus 1 times minus 6? Plus 6. What is minus 2 times minus 3? Plus 6, because 2 negatives together make a positive. Okay. But as you can see, when I add them, if I add 1 and 6, what do I get? 7. If I add minus 1, add minus 6, I get minus 7. So you get a completely different b, depending what you use. So having all of your different options is really useful. But in this example, what do we need to add to make b? Well, b is 5. Yeah? Hopefully you can see b is 5. What do you add together to make 5? 1 and 6 is 7, can't be that. 2 and 3 is 5. Oh, must be that. So bang, I found it, done. All I've got to do now is write those numbers in. So that is plus 2 and plus 3. And that is us done. If we expanded this bracket out, it is going to give us exactly this. And we can check. X times x is x squared. X times 3 is 3x. 2 times x is 2x. And 2 times 3 is 6. Remember the bits in the middle, the x's go together. So we've got x squared. 3x add 2x is 5x. Plus 6. And as you can see, that is exactly the quadratic that we started with. So, 2 numbers that times together, multiply together to make c, and add together to make b. How do you do that? You list the factors of c, and you just find the ones that make b. A question I often get is, could I write it plus 3 first and then x plus 2? Yes. If you put the numbers in the other way around, you're still going to get the right answer, because when you multiply, it doesn't make a difference which order you do it in. Okay, so if you put the numbers in the brackets the other way around, absolutely fine. Okay, so we're just going to use that method now where we list the factors of C. We take C and we list all the factors, and then we just check which ones add to make B. Okay, so again, that is the same question. I'm not quite sure why that's there. Maybe we will change, let's change the 5 to a, what should we change it to? Let's change it to a, well, let's leave it as a 5 actually, and we'll make this over here, what should we make this? We'll make this 4, okay? We'll make this 4. So what does this say? We've got a quadratic that is x squared plus 5x plus 4. We need two numbers that multiply together to make C, which is 4, and add together to make B, which is 5. So we're going to list the factors of C. So we're going to list the factors of 4. Okay. What makes 4? 1 times 4 is 4. 2 times 2 is 4. So you need to know your times tables. Hopefully at this point you're like, oh, times table is really useful. 2 times 2 is 4. We could also have, to make a positive, we could have two negatives. So we could have -1 and -4. And we could have -2 and -2. Because if I multiply those together, I also get +4. But it changes my B drastically. So just go down the list. Which ones add to make 5? Well, 1 add 4 is 5. Done. Found it. So we probably could have stopped there. But just to show you, listing all the options is really useful. What does that mean? It means I've got two brackets. I definitely need an x because that's the only way to make x squared. And then I need a +1 and a +4. And if I multiplied that out, I'm not going to do it to save time, but you could multiply that out and you would realize you get the exact same quadratic we started with. Okay, so example 3. Factorize x squared plus x minus 12. So I need two numbers that multiply together to make C, which is -12, and add together to make B. But oh, there is no B. However, we know that x means 1x, okay? X means 1x. So I need two numbers that add together to make 1 and times together to make -12. So factorizing, we're going to have two brackets. We're definitely going to have an x in each one because x times x is x squared. Now we need to work out the numbers. So same method as always. Let's list the factors of -12. So this is where positive and negative understanding is really useful. If we list the factors of -12, how do we make a minus? What do we multiply to make a minus? Well, if you check your information sheet up the top, how would you make a minus? Well, these are minuses. How do I make these? From a plus and a minus, or a minus and a plus. So I need a mixture. I need a mixture of signs. So keep that in mind. How do I make 12? Well, 1 and 12 makes 12, but I need a -1 and a plus 12, okay? Because -1 and plus 12 times together makes -12 because a mixture makes a minus. However, you could also have 1 and -12. So the same numbers, just the opposite way round with the negative and positive. And that's really key that you list those. Don't just put -1 and 12. You have to also put 1 and -12. What else makes 12? 2 and 6. So I need a -2 and a +6, or a +2 and a -6. You have to have the flip. Okay. What else makes 12? 4 and 3. So you could have -4, or -3 and +4, or +3 and -4. That would be all my factors of 12. And as you can see, it looks like there's loads there. The reason there looks like there's a lot is because we've had to do the opposite signs. we've had to do -1 and 12 or 1 and -12, because both of those will multiply to make -12, but they will add to make something very different. And we need to know which one is going to work. Well, let's just check. -1 add 12 would be 11, so it's not that. 1 take away 12 would be -11, so it's not that. -2 add 6 would be 4, so it's not that. 2 take away 6 is -4, so it's not that. So it's got to be one of these ones down here. -3 add 4 is 1. And look, -3 take away 4 is -1. So it can't be that one, because we need b to be +1. So it has to be this combination here. What you'll find is, the more you do these, if this is new to you, I recommend writing out all of your factors. But when you do these, and if you're in year 10, 11, and you've done a lot of them, you'll start to just be able to see the numbers straight away. You won't have to write all your factors down. You'll just know which ones they are. But when you're practicing, definitely do this method. So we can say this is -3. Change to red. -3 and +4. So that is that one factorized. So again, find the numbers that multiply to make C, which in this case was a negative, and add together to make B, which in this case was a positive. So we needed a mixture. Okay, 2 left. 2 more examples, and then you're going to have some time to practice. Factorize x squared minus 3x minus 18. So again, we're going to need 2 brackets with an x in both, because x times x makes x squared. We need 2 numbers that multiply together to make c, which is the number on the end, the whole integer on the end, and add together to make b. Now, as you can see, I've highlighted these negatives because they are attached. B is 3, yeah? 8x squared plus bx plus c. B is -3 and c is -18. So, what we're going to do, as always, we're going to list the factors of c, which is -18. Okay, what makes -18? Well, to make a minus, I need a mixture. So I need a positive and a negative. So what makes 18? We could say, and hopefully at this point, I'm not going to write 1 and 18, because b is 3, and 1 and 18 is going to make nowhere near 3. So we could say 3 and 6. 3 and 6, but I need a negative and 1 positive, because of the mixture, times it together makes a minus. And I could also have a 3 and -6. Let's just check these. What is 3 add 6? -3 add 6 would give me +3. So it can't be that one, because I need -3. What would 3 take away 6 be? 3 minus 6 would give me -3. Oh, that's good, because b is -3. So we found our factors there, 3 and -6. Putting those in, we're going to have +3 and -6. And again, if you wanted to, you could expand that out and check for yourself that it does in fact make x squared minus 3x minus 18. Okay, last one. Last one, we've got p squared. So we're not dealing with x's anymore. They don't have to be x. P squared minus 7p plus 10. What do we need? Well, we need 2 brackets because we are factorizing. So 2 brackets. What's going to have to be in the bracket? Not an x. It's going to have to be a p, because I need p squared. So that would be p and p. I need 2 numbers that multiply together to make c, which is 10, and add together to make b, which is -7. So I'm going to list my factors of 10, and I need them to add to make -7. Well, how do you make a positive? We've got 1 times 10 is 10, 2 times 5 is 10, If we check those, what's 1 add 10? That's 11, so it's not that. 2 add 5 is 7, it's not that, because I need minus 7. Minus 7, not 7. But remember, how else do you make a positive number? 2 negatives, so we could have minus 2 and minus 5. Minus 2 times minus 5 would be plus 10. But what is minus 2 take away 5? If I add those together, what do I get? I get minus 7. So that is the combination of factors we need. So in my brackets we can write p minus 2 and p minus 5. And if I expanded that, it would 100% give me p squared minus 7p plus 10. So that is the end of Factorizing Quadratics 1. Hopefully that you followed along with the ax squared plus bx, because as you can see, the way I was explaining that, I was using a and b and c. I was using c and b in my explanation. I need two numbers to multiply to get c and add to make b. If you can get into that thought process and understand what a quadratic is in terms of ax squared plus bx plus c, factorizing becomes very easy given this technique. Okay, times table is really important that you know your factors. Positive and negative numbers, what I've put at the top for you, really, really crucial. If you don't know that, you're going to sometimes miss factors because you've not listed the mixture or two negatives, and therefore you feel like you can't factorize it because you've actually missed writing down some of your factors. So take it step by step, write down all your factors, and you can see which ones add to make b. Okay? So hopefully you learned something there. What you've got lined up after this is lots of questions to practice where you've got all positive, some negative, a mixture of positive and negatives. And I've got all the answers lined up for you at the end. So that will just be there for you to look at so you can mark it yourself. Thank you for joining in. Hopefully you did learn something new there, or if it wasn't new to you, you've made your understanding a lot stronger. And I will see you in the next one. This will be very, very useful for those of you that are following the algebraic fractions lesson series. The next lesson on algebraic fractions will involve this technique here. Okay, so I'll see you in the next one.